All right, this is the practice chapter 11A test, and as always, I am the amazing Mr. Jansen. So away we go. If we look at this first one, it's asking us to find the value of x. If given all these values plus x has an average of 14, what does this x value have to be? So again, we would set it up this way. We'd do 10 plus 10 plus 18 plus 15 plus x. Those are our values, and to find the average, I add all those together and I divide by how many I have, which is 5. And we want to know what's going to make that equal 14. So now from here, I just need to simplify that a little bit. So in the numerator, if I combine the like terms, that's going to give me, let's see, 20, 38, looks like a 53 plus x all over 5. And if that's going to equal to 14, I could just simply cross multiply. So here, if I cross multiply, that's going to give me a 70 equals 53 plus x. I subtract the 53 from each side, and I find out that x equals a 17. And that's it. And I can easily check that by plugging the 17 back in and finding the average. For number 2, it says to simplify this thing. And right here I have multiplication and I have an exponent. I'm going to do the exponent first. And since that's a negative exponent simply flips this thing, so it sends it to the denominator, so it becomes 1 over 4 to the positive second. Okay, that's what negative exponents do. And now I do the exponent now that I've changed to a positive. So that's going to be 1 over 4 squared, which is 16. And now I have negative 2, which is negative 2 over 1 times this. That's going to be a negative 2 over 16 reduces to a negative 1/8. Okay, so again, the negative exponent flips it. So that gives me a negative 1/8. Again, the negative exponent flips it. Then we raise it to the second power and simplify from there. Okay. Number 3, it's just asking us to add these, so we're just going to combine like terms. So here, when I add the like terms together, so pairing up my like terms, the 3x squared and the 12x squared is a 15x squared. The negative 4x and the 5x is a plus 1x. The negative 5 plus the negative 1 is a negative 6, and that's it. Okay, I combine like terms. For number 4, we're subtracting this time, and I would recommend just distributing the negative sign or change it to adding the opposite. So if we change this to adding the opposite, it becomes a negative 6x, 6x squared minus 6x plus 4. That's going to be plus a negative 10x squared plus a negative 2x plus 9. Okay, so change it to adding the opposite. Now it's pretty simple to combine my like terms. Overshot that one a little bit. There we go. And so when I add these up, the 6x squared and the minus 10x squared is a negative 4x squared. The negative 6x and the negative 2x is a negative 8x. And then the 4 and the 9 is a plus 13. And that's it. Number 5, I'm going to distribute or FOIL. So I'm doing the 7w times the 3w is a 21w squared, and then a minus 14w. And now I have to distribute the second term as well, the negative 1. So that's going to give me a negative 3w plus 2. And now I combine like terms, the 2 in the middle. And that's going to give me a negative 17w. That's a terrible looking w. Let me try again. It's 2. And that's it. For number 6, it's essentially the same thing here, except I have 3 terms. I have a trinomial times a binomial, so I have to just distribute this y to all 3 terms over here. So that's going to give me a y cubed plus 3y squared minus 2y. I distribute the negative 3. That's going to give me a negative 3y squared minus 9y plus 6. And now again, I combine like terms. It's going to be a y cubed. The y squared terms, those cancel each other out, so that's 0. And then these terms, that gives me a minus 11y. And then the plus 6 kind of tags along for the ride. And that's it. Okay? If I look at the next one, rationalizing the denominator, I need to eliminate all the radical terms from the denominator. In order to do that, I'm just going to multiply this thing by the square root of 6 over the square root of 6. And essentially what that does in my denominator, I'll do the denominator first, is because they're both under the square root, I multiply them, that becomes the square root of 36, which that's a perfect square. Up here, this is just 2 root 6. So that becomes 2 root 6 over the square root of 36, which is a 6. And now from here, I can just simplify this a little bit. The 2 and the 6 reduce to a 1 over 3. So it becomes the square root of 6 over 3. Okay? Number 8, it says the width of a rectangular pool is 2p minus 3. The area P of the pool is 4p to the fourth minus 17p squared plus 14p minus 3. And we want to know what is an expression for the length of the pool. So if this is the area of the pool, and I'm given the width of the pool, to find the length, I would just divide. So I'm going to take the 4p to the fourth minus 17p squared. And when I do this, when I do my division, remember I need to put zeros in for missing term. I'm missing the p to the third term, so I put a 0 in its place. Write everything else down. And I'm dividing by the 2p minus 3. Okay? So now 2p times a 2p to the third will give me the 4p to the fourth. So then I multiply. And again, when I'm multiplying here, I'm using my distributive property. So I'm distributing that 2p to the third, which gives me a 4p to the fourth minus a 6p to the third. And now I'm going to subtract, which is the same as adding the opposite. So that's going to give me a 6p to the third. I bring down the next term, which is the 17p squared, and now I start the process over again. 2p times what gives me the 6p to the third? That's going to be a 3p squared. Again, I distribute, so that's a 6p to the third minus 9p squared. I'm going to subtract, which is the same as adding the opposite. And when I do that, that's going to give me a negative 8p squared. I bring down the 14p. And now I do this process again. 2p times a negative 4p is going to give me the negative 8p squared. So that's going to be a negative 8p squared plus 12p. Again, I'm subtracting, which is the same as, I'm going to have to take this off to the side a little bit, adding the opposite. So when I do that, that's going to give me a 2p. And now I bring down this other term, the negative 3. Oh, not ready for that line yet. And now I'd start the process over. 2p times a 1 will give me a 2p minus 3. And now I subtract, same as adding the opposite. That gives me a 0. So there's no remainder here, which means my answer is the 2p to the third plus 3p squared minus 4p plus 1. Okay, divided evenly. If I did have a remainder, I would put that over the thing I was dividing by, the 2p minus 3. Okay. For number 9, we're talking about Jane, and she took a 100-mile vacation, and she basically drove twice as fast on the second half of the trip as she did on the first half of the trip. And we want to express her time for this trip using fractions and some things here. So the first thing we need to understand is that distance equals rate multiplied by time. That's what we're going to have to use for this. And we're going to basically split this into the first half of the trip and the second half of the trip. Okay, so when we think about her first half of the trip, it tells us she went 50 miles for the first half of the trip, same as the second half, but the distance is 50 miles. The rate, it tells us that x represents her speed on the first half, so x is her speed on the first half multiplied by the time. And again, we don't know the time yet for the first half of the trip. The second half of the trip is very similar. It's 50 miles, but this time the speed is twice that of the first half, so it's 2x times the t. And now we're just going to have to solve each of these for time. Okay, I want to express time, so here I have to divide each side by x. That leaves me with t equals 50 over x. Over here, I have to do the same thing. I have to divide each side by the 2x. And when I do that, again, this is just reducing. The 50 and the 2 reduced to a 25 and a 1. So in other words, the time for the second half is 25 over x. And really, it's asking me for the total time. Well, if I want the total time, I take the time from the first half of the trip plus the time that it took for the second half of the trip, and I add them together. And here, I need common denominators, which I already have. So I add these together. It's 75 over x. And that's it.